Absolutely perfect. So our apologies for the surprise here. Rich Sweetser, the U.S. DOE CHP eCatalog coordinator, is going to present a tutorial on the eCatalog program and how to use it to find packaged CHP solutions, but also much more. The catalog provides a unique platform of engineering data from DOE reviewed and recognized CHP equipment and suppliers. A lot of technical data in the catalog, but also yesterday, to my great surprise, but it shouldn't have been, it's also chock full of really good information, industry information, updates on policies, and it's an incredible one-stop shop for really good information, I think North America and the EU as well. When Rich took us through a test drive for this yesterday, I was sorry that I had not dug deeper into all the features, and I believe that Rich is going to get into some of that this afternoon in this 1 hour. So I think you're going to find this a useful tool, a useful tutorial. I am Tom Bourgeois. I'm the director of the New York, New Jersey CHP TAP Technical Assistance Partnership. We're a few minutes late, and I'm going to get out of Rich's way and let him get going. We are going to save time. Please hang on for Q&A. We'd love to hear your questions. Please pay attention. I think you're going to find that there's a lot of really good information here. With that, I'll pass it over to Rich.
Thank you, folks. And I apologize again for the foibles of Microsoft Teams that happens occasionally. And I'm actually on the wrong piece. Let's start off with a presentation. Basically, the reason why the U.S. Department of Energy back in 2019 decided to push out this eCatalog was it was all about risk reduction. We found that combined heat and power systems were very interesting, very good at energy savings, but not necessarily everybody understood how all that worked together. And the whole concept was by putting out good information, good DOE recognized packagers and solution providers, I'll explain that in a minute, as well as comparative package systems, it would benefit the industry. And basically, we have to start and give a tip of the hat to our friends at NYSERDA, because back in 2013, NYSERDA started this process, the idea of having an entity, a recognized entity that reviewed technologies and applications and products was a good thing in the CHP world. They started this process in 2013, and it ended up finishing up in 2020, and it was very successful. What they found was by doing this kind of a process, they were able to reduce actual costs of systems and time from discovery to commissioning about a little over 20% in each case, which was rather remarkable. And at the same time, the uptake for CHP systems grew as the incentives were actually being ratcheted down. So DOE took notice of this. DOE listened to NYSERDA at the time and said, this is probably good for the rest of the country. So why package CHP systems? Well, I went through this slide with the folks yesterday, and we had something called market trends, and we had a general graphic here. But I went back to part of the eCatalog, which is our news and events section, and really looked at the news over the last several months as to where CHP was moving. And I can tell you, we were moving in the carbon reduction. We are still very powerful on the resilience side. We are moving towards what we call low risk and no regrets applications. I'll get into that in a minute. We're still doing a lot of non-traditional, which means smaller systems under 10 megawatts, really focusing in on not just chemicals and petrochemicals, which is what we were known for originally. And we're also looking at how to become more flexible. So it's all in those areas. And I just wanted to highlight these. You know, this first one is Kroger. Kroger is a food chain, but they are using essentially CHP to take a food waste digester and they take their food waste and turn it into useful energy. Next one, as we go to the right, is new ways of selling the technology or products. Is Capstone is engaging in a rental fleet. What better low risk is to take a certain term rental operation. The next one is very different. It's our first 100% hydrogen CHP system being installed in North America. Was just announced in June of this year. Pretty interesting. If we go up to the upper right-hand corner, we go to another 2 megawatts that go to expand the greenhouse footprint in Ontario. Ontario has been a very strong user of CHP systems in greenhouses that help with their constrained areas. Dropping down one, which is even more interesting, that just came out yesterday, is INEO with their Jenbacher CHP systems is actually taking landfill gas and as its energy source, but also working to create the first California hydrogen production facility, which is rather intriguing. Bottom left, we can go in and look at another bioenergy plant, RNG, where CHP is really creating RNG and putting it into the pipeline. The next one over to the right is Caterpillar, when they announced that they acquired a carbon sequestration company for small systems, really looking at the combustion turbines and reciprocating engines, be able to provide using natural gas and having carbon capture and use or storage to drive that down to zero carbon. Next one over is this whole area of controlled environmental agriculture, whether they be vertical farms, grow houses, or greenhouses. It's a very interesting play. In the greenhouse side of the world, we actually do use tempered exhaust gas to do CO2 dosing to the crops and increase crop production about 35% or more. So that's an interesting play. And last but not least, we do need to mention that CHP still works on natural gas, even in the city of New York. This is the Marriott at Times Square, the beginning of the year, putting in a number 4.2 megawatts of CHP system to save energy and keep the reliability up in that particular site. Those are sort of the trends that we see right now in the marketplace. We still see this movement to non-traditional applications. The green in the bars is basically what we call technical potential, and the blue in the bars is existing systems. Largely, if you look at the blue space, it pivots to the left, which is our traditional chemicals, refining, pulp and paper, food processing, and so forth. And then you can see the applications in the green on the right, which is a growing area, is really colleges, universities, district energy systems, hospitals, healthcare, multifamily, which is also important as well. So that's an interesting trend. The next element, when we look at this technical potential, when we designed the eCatalog, we said, well, where are we focusing? Are we focusing in this literally the full range, which is up to multi-megawatts? We just had in Pennsylvania a 250 megawatt plant startup this year. Or are we going to focus differently? And we basically looked at this area of 0 kilowatts up to 20 megawatt size. And that literally represents 79% of the total technical potential. And that's where we decided to focus. Now, package systems. Why package systems? Well, this is sort of the what. They really basically, you can see they're either packaged or modular. These big systems are modular. So you can get systems up to literally 20 megawatts that come in a series of modules that come together. The real reason why we want to look at those systems is they're pre-wired, they're pre-piped, they're properly ventilated, they're sound attenuated, they're fire rated. They've got all the right systems, and they've either been fully tested out in the factory, or the components have been tested out and they've been designed and used before. This is a big deal because as we look over the history of CHP, we've seen not just mismatch in thermal energy, but we've also seen some silly issues that don't need to happen that packaging just removes from the table. So that's why we're interested in this whole packaged and modular approach that started up literally with the help of NYSERDA in the early 2000s. Now, the eCatalog itself, actually, if you look closely, you can see this is the home page, and you can see this event is featured because we're today. This is the event on in part of our news and events section. The eCatalog itself basically has the stakeholders are what we call packagers. These guys actually make the package systems. Solution providers, they can be packagers, or they can be independent, like ESCOs or people selling energy as a service. They do installation, commissioning, and provide the full bumper-to-bumper warranties, or not warranties, service and maintenance agreements that are out there. And customer engagement partners. Customer engagement partners are folks like NYSERDA. They are folks like National Grid and other folks, utilities. So basically, state energy offices and utilities that have CHP programs that focus on CHP. What we do in the catalog is we give you pre-engineered, pre-tested package systems that DOE that meet or exceed DOE performance requirements, and that DOE reviews each and every element of it to make sure you can legitimately compare one system to another. Our target audience basically is end users with engineering staff, consulting engineers, utilities, state energy offices, regulators, federal agencies, and other project developers. And basically, that's the fundamentals of the underpinnings of the technical part of the catalog as far as how you look at the package system, but there's a whole lot more that we'll go forward in a minute. Just some facts and figures. Was launched at PowerGen in 2019, just before the pandemic. Great timing we had, but we didn't know the pandemic was coming. We today have 42 recognized packagers, 25 solution providers, and 340 package offerings. The offerings literally span from 24 kilowatts up to 16.7 megawatts right now. Some of the important things to see is we're not only dealing with reciprocating engines, microturbines, gas turbines, but we have back pressure steam turbines, particularly looking at replacing pressure reducing valves, which is a great way to save energy and reduce the electric need or electric burden on the grid. We've got our organic Rankine cycle systems that can use either geothermal energy or waste energy, anywhere from typically 1,000 degrees Fahrenheit down to 300 degrees Fahrenheit. They're great use of that type of energy. We list 57 hydrogen blend compatible. That's a small number. We've got to get our guys back in there updating the data, because all of these systems can take hydrogen blends. We've got 500% hydrogen systems already in the catalog. Of course, we've got normal digester and landfill gas systems in as well. And we've got 17 what we call customer engagement partners in that were part of an accelerated program, which we can talk about later if we have time. I did want to give you a coming soon. This is not up yet, but we are looking to put in consulting engineers and CHP consultants that have good CHP experience and offer that out to the public so that they can tie the consulting engineers that have the experience or consultants as well, and they have a resource that they can go to. Now, without further ado, we'll push the button and see that it works. Okay, we are now live. This is the live eCatalog. The purpose of the landing page really is to talk about this risk reduction and the fact that all of these folks that are in here have been reviewed and really have the experience that they say they have, and that the equipment will operate like they say it will. So what we do is, as far as I'm going to start with the search, which is what the engineers really need to see. And you get no results unless you put a zip code in. Unfortunately, New York has pretty easy zip codes to find. And what you're going to get here, what you're going to get is a series of cards. And that all I put in is a zip code. So you literally will get 340 packages if you dig down here, because all I put in is zip code. On the cards themselves, you get a great deal of information. You get the output of the system, you get the electrical, thermal, prime mover, and grid connection capability. But you also get these badges here, which can become very important as well. And if you look at the badges available, it can be sold in the zip code. That's important when you got different distributors. Is it offered by a solution provider? is there an assurance plan? Assurance plan, and by the way, if you hover over any one of these, you can see it tells you what it is. It basically, it's normal service and maintenance agreement, but it also goes beyond that. It goes beyond to an availability guarantee and a maximum response time of 12 hours to an unintended outage. CE means, is it supported by a utility or a state program? Outdoor installation. Is it, if you have a footprint restriction, does it fall within a footprint? This tells you if it's hydrogen blend capable. And this blue over will tell you the number of units that the company has made, packaged or not packaged, number of CHP systems. We've got to get after some of our people to get better at doing that. I can tell you Martin Energy, for example, has about 450 units. They just haven't gotten us the data yet. You can see 2G has 3,850. And actually, that's 2 years old. So you can go down and get a great deal of information here. But you can also start selecting, like you do from Amazon on the left-hand column here. Do you want just a packager, or do you want a solution provider, or do you want someone providing energy services as well, or financing? Then and basically that'll reshuffle the deck. The next thing for an engineer or someone who wants to know is you need to pick a size. And in case you don't understand how to pick a size from the electrical, which we don't normally do, we have a Help Me Choose button that allows you to go in here, pick an application. All you need to do is to put in how many kilowatt hours your application uses a year, and how many hours. This is a hospital, 8760, and it's going to tell you it's probably going to be about a megawatt. So you hit there, and you can see that falls right in there. And by the way, if you want to basically take this megawatt system and multiply it out by multiple units, you can actually, it'll give you multiple unit solutions as well. But just to keep it a little cleaner, we'll leave it there. You can see my friends at Ineo Janbacher have been very busy. They put a lot of different potentials here, and you'll see the differences here: landfill gas, natural gas, digester gas. So you can see how all that plays out. You can obviously put in, is it going to be outdoors? That would change the requirements. Is it pipeline or RNG, pipeline natural gas, propane, digester gas, landfill? Then that filters various things out. We'll just pick natural gas for now. And we want grid island with black start capabilities. And let's just say we want hot water. And then it starts to narrow down into a series of different opportunities. What you get to do here as an engineer, you can go in and find details, which will give you an immense amount of details. You can see, for example, package experience. This happens to be Northeast Energy Systems. And you can see they built 282 systems. So they probably know what they're doing. They got 31 of them in New York. They've got 8 of this package, in fact. But then you come down and you're going to find technical data you will not find anywhere else in the world. I've never, other than the old NYSERDA catalog, you don't find this for a CHP system. So you get three power levels, you get 3 ambient temperatures, you get essentially the net electrical efficiency, you get the output, the net output, and then you get all the thermal data. So you know, again, in this case, it's against 180-degree hot water supply. You can, in this machine, you can provide up to at least 194 Fahrenheit, if not a little bit higher, but that's how you adapt it for your particular application. You can go further, you get emissions data, and all our lean burn engines, we require them to not put after treatment, because we know we can take NOx and CO and drop them way, way down if you're going to deal with them with SCRs and oxycatalysts. You get weights and dimensions, and you get a schematic that tells you what you're going to get and what to expect. All of that can be downloaded in the PDF, but we can actually go back here and we can come and compare, which would be really interesting. So I can compare 4 different systems that are relatively the same size at a time and compare selections. And I can get a comparison here. By the way, I can download it as an Excel or PDF, and you can start comparing performance and other data here, which is really good if you are an engineer. So from the engineer or user perspective, this is the type of information that you get from the eCatalog, which we found to be very valuable for the engineering community out there, for end users, and for agencies that need to understand what's available. Because you get a very wide blend of companies that are available. And you can go back up here to the packager, and you can find out a little bit more about the packager and get direct contacts to all of these packagers that are available. And you can sort the packagers by where you are. New York, you get 31 of the packagers that service in New York, as an example. So that is part of what the user experience is, to really understand what CHP systems are available anywhere in the country right now. Now, this is not complete, because I can tell you that every one of these packagers has a lot more incrementation in system sizes. So there's a lot more performance. So don't just say, oh, I don't have exactly what I want. You can get what you want. It's there. Yeah. And by the way, if you have any questions, we do have a site guide that's pretty good and gets you around, and also has the place where if you have a question, you can send a question into the eCatalog and we'll give you the best answer that we can give you. Now, again, this is more than just the selection. The selection part's really important, and it's also important to understand the rigor that these folks go through to get listed in the eCatalog. It's not just, here's our performance. They actually give us all of that performance. They also have to give us 100% test data for the ISO condition. We say our ISO condition is 59 degrees for all these systems. So they have to give us that. They have to give us test data, performance data for thermal and power, and the emissions data at that point. So we can check that against the performance data they put in the system. They also have to give us single line diagrams that are not public information. They have to give us O&M manuals. They have to give us commissioning documents, installation documents, warranties. All of that type of information is part of the due diligence that we do, so that anyone that looks at this information can rest on the information that we've checked out, and this is indeed correct. Moving on to a couple of other aspects. We do have a fairly robust basics and benefits side, and many of you that haven't been for a little while, you're going to see back pressure turbines and ORCs. We're just bringing those out, and we expect to get more systems in the catalog. We don't have a lot yet, but we are actively going out talking to the ORC manufacturers and the back pressure turbine manufacturers to get more of this in, because we see this type of systems for particularly for industrials or any steam system where you got pressure reducing valves or waste heat out there. That becomes really important to be able to turn that waste product into electricity, so that you don't have to generate electricity from any other source. We've got, these are well brought out, so you can find out a lot of information. I did want to point out the benefits of CHP. If you want to walk down this at some point in time, it is helpful, because we start out with, okay, natural gas CHP, because natural gas CHP versus many things at the margin of the electric grid right now, and that's going to, at the margin, the electric grid's going to go out for a number of years. CHP will be beneficial as far as CO2 reduction, as well as many other things, particularly resource efficiency. Resource efficiency is a very important thing. So you can take a look at this and see all the background. It's very transparent. Then we talk about decarbonization. Obviously, CHP has been in the biogas business for decades. We've done landfill gas, we've done digester gas, all sorts of digester gas for decades. We can take that treated raw gas, we don't have to take pipeline quality gas, and turn it into good energy, both electric and thermal. But we're also participating in turning it into RNG when it gets further processing. As you can look at that type, any type of digester needs the heat that CHP gives off, and obviously there's a lot of power consumption in creating RNG. So it is a place to use CHP. But also the next element is hydrogen. I've already told you there are currently 5 hydrogen systems in the eCatalog. There are more than 5 systems available today. Most of the reciprocating engine people are working very diligently to get 100% of their, actually all of these folks are, let's leave the fuel cell people aside because they're already there. All of these other folks are going to be at 100% hydrogen by certainly before 2030, many well before 2030. But the interesting thing about many of these projects are that you're not locked in. The interesting thing with most of this equipment is over time, you will be able to convert. Not all the systems, not the old systems, but many of the new systems, you will be able to convert them from, if you wanted to start out with natural gas for economic reasons, and then convert them to hydrogen blend or RNG. Certainly any of the RNG is eminently compatible, but perhaps bio blending, and then ultimately to 100% hydrogen. So there's many opportunities that you're not locked in and you haven't created essentially a boat anchor after a few years. These will have the ability to transform. So I think it's important to see that. We do show this is national. Obviously, it would make more sense to do things for NISO or in the case of New Jersey PJM or others to get those kind of curves to show when you really need to think about or where CHP is beneficial time-wise and where it has to be changed over in fuels or whatever. So that's a very interesting thing for if you want to go through that. We do have a lot of information on financing. We see a lot more of financing moving over to what I call other people's money, but we see CPACE is a very good thing. New York has a lot of CPACE activity, and CHP generally qualifies for all of that type of activity. And we also are seeing a lot more energy as a service come out, so that's going to be rather interesting. We have an immense field of resources here. Our project profiles are our case studies. You can go into this database and pull out project profiles either by application, by state or location, by a whole host, by prime movers, and find out at least what DOE's looked at and has posted as their case studies. As far as resource technologies, you can get fact sheets here on the various resources. We're just in the process of updating the reciprocating engine one right now, which should be posted in a matter of weeks, if not a couple months. That's helpful if you don't need to understand more about those. We have 2 installation databases now. If you go in here, we've got a CHP Installation Database. If you want to find out who's done what, where, anywhere in the country, this is the place, the authoritative source to go. And developing a microgrid installation base because actually this is one of my favorites. This is one I worked on. This happens to be the public safety headquarters in Montgomery County, in the state of Maryland. There's 2 megawatts of PV arrays here. And down here in the corner here, this little thing here is a 865 kilowatt CHP system with an absorption chiller on there. And just a point of fact, when this thing was first commissioned a couple of years ago, 75% of the carbon reduction came from this little CHP plant. That's because of the emissions of PJM at this point. So there's some interesting applications here worth your taking a look at. We do have our list of packagers, and if you get a great deal of information on the packagers. These are our solution providers. Remember, they're the folks that can install, commission, etc. Our customer engagement network is going to be growing. This was the initial group that came together under a CHP accelerator, or DOE accelerator, which was a DOE-focused program that we brought together a number of folks, and this is basically the folks you see we brought together to essentially talk about CHP, talk about the eCatalog, make sure all these things work together. You can see that NYSERDA was one of the original one that helped start. We've got the New Jersey Clean Energy Program, so that's sort of up in your neck of the woods as well. That is now moving more into the eCatalog, and we hope that will grow. You have here the TAPs. You've got Tom Bourgeois down there in the lower right-hand corner. He he is right here in the New York, New Jersey TAP, but the footprint covers the rest of the country. And he can tell you more about the TAPs, but although I do work with the Mid-Atlantic TAP, we do a lot of these things: user engagement, stakeholder engagement, technical service. I'll let Tom chat about that more, but if you need to find someone there. And we have a pretty powerful, interesting news and events section. You can see, we do have our event here. This is the event you're on right now. If you go over to the right, I talked to you earlier about this INEO CHP engine system that's basically, and by the way, ready for H2. This system will be able to be converted. It's doing landfill gas right now. It'll be able to convert to 100% hydrogen over time, which is the whole future there. You can come in and you can find out a lot of information about what's going on. The right-hand column is our partner column of information. So that's all the essentially the packagers, solution providers, and the customer engagement partners that are in the eCatalog. The center column is basically for events. So these are events that should be of interest to the CHP, people interested in CHP and saving energy and microgridding and that type of thing. And the left-hand column is general information where you can find out all sorts of things. And this week, the general information we will be, and even all the columns will look globally. This is where you could find out in June of this year, the EU Parliament basically declared natural gas, CHP, and nuclear power green energy for the near term. And I don't know when that's going to when the near term ends. So they basically recognize that they need to move forward with both nuclear and CHP natural gas as part of their near term solution. And basically, the only other thing I want to present formally, and then we'll get back to discussions because I'm hoping we can generate a whole lot of discussion topics, is it's pretty easy to log in. So I'm going to log out just for a second. You see it says sign in. You just basically create an account. To create an account, you need a email address. You actually need an email address, a zip code, and a password. And once you do that, and I'm going to go in differently right now, you get a dashboard. This is your dashboard. Your dashboard allows you to save searches, which is important, particularly if you're an engineer and you got multiple sites. So you can basically save searches. That being logged in allows you to also do the comparison. You can't do the comparison I did of systems without being a user. If you want to become a packager, solution provider, part of the customer engagement network, or enroll in this Trade Ally network that we're coming up in the future, all you need to do is just click here. For example, Trade Ally, you get your questions here, and it's just a matter of submitting it. We review it and approve it, and you're part of that Trade Ally network. So it's not really hard to do any of this stuff, depending on where you are in the process. So with that, and I'm getting pretty good at this. I've done this too many times, Tom. So I want to bring it over to some questions.
Absolutely. Well, we have one in the chat from a New Jersey's Clean Energy Program Manager.
Okay.
Can we? I don't know. Do we turn on the mic or do we just? Did you want to speak up?
Yeah, I'll speak up. Good afternoon, everyone.
Hello.
Yeah, so my name is Izu Panu. I work for TRC, and in respect to New Jersey's Clean Energy Program, I have one of my colleagues on the call as well, Tiffany Lewis. But we were just on the call to let everyone know that New Jersey's Clean Energy Program provides. We have a program for combined heat and power that provides incentives for those organizations that are looking to implement CHP on any of their new construction or gut rehab projects.
Thank you.
And we want to emphasize that because right here under Customer Engagement Network, there they are.
Yeah.
There you are.
And if you want to, by the way, if you need to update this, let me know. But this is the easiest, quickest way I know to get to them.
Yeah, and I think I guess
That's the direct program team manager, I
yeah,
believe.
that's the program team manager. Our office has changed though. We don't go out the Woodbridge office anymore. We're in the New Brunswick office, which is
Well, I'm going to give you guys something to do.
perfect.
Contact me later, and we need to update this so it's current. So,
Okay.
So the people that need to
Definitely.
get to you can get to you easily.
Definitely. That sounds good.
So for those of you on the line who want to do CHP in New Jersey, you can get some money. That's what
Yeah.
I just heard.
Yep. We always get it's no such thing as free money. The funding for the program, first of all, funding for the program comes from what we call the societal benefits charge. It's a line item on every ratepayer's utility bill that you pay into every month. So that's where the funding comes from. So why not utilize and tap into that pool of money. So it's technically free money that you can apply towards your new construction or gut rehab projects. So
Be sure and contact me. We'll work on that.
yeah, definitely.
Okay.
Tom,
And-
a question from Ashley Hahn.
Ashley, great.
Oh yeah, hi. Hi, my name is Ashley, and I'm a law student at Pace University. Very interested in this field. I have a quick question about CHP, and it seems like a lot of businesses and industries are participating in this, and I'm wondering if there's a room for residential uses for CHP, and I want to hear your thoughts on that. Thank you.
Boy, there have been many attempts at looking at residential CHP. The problem with residential CHP, and this is me talking, not DOE, as an engineer, is that the utilization of thermal and electric energy is very spotty in homes. Now, multifamily is another story. If we're talking single family, it's pretty difficult because you're going to use thermal energy for hot water in the if you look in the summertime and shoulder months, in the morning and maybe in the evenings, and that's about it. CHP works and pays for itself when you have coincident thermal and electric power when it's running. So that doesn't give you a lot of run hours. In the wintertime, you can run longer for heating, but you've got to also understand that the thermal, you've got to deal with the electric because in nighttime, you don't need the electricity. So if you put a battery in there, which costs you more money, then you can do something. But it's really not expensive. It's really too expensive as far as what I've seen right now.
Got it. Thank you.
I
Now,
think
by the way, there's some interesting new products coming out though that will change some of that. There's a lot of people working on this subject, and I think that will change.
Yeah.
Because of some new innovation. But right now, it's tough.
Got it. Oh yeah, this was very useful and informative. Thank you.
Well,
Thank you.
I scanned down the list and I see a lot of people here from a variety of different areas. I'd love to hear your viewpoints. From my perspective, this is a spectacular tool and easy to use, but I'd like to hear, we have some hospitals, we have DEC, we have NYPA, we have New York Power Authority, and we have New York ISO. And I think each of you might have somewhat different interests, but no matter who you are, I mean, you can look here, you can find out the DEC people, there's emissions information, wastewater treatment plant infrastructure, illustrative cases like best practices. This is chock full of best practices. The information on what Kroger's doing, information. We have, I believe, somebody from Ontario, and we talk about some work going on in Ontario with high-tech greenhouses. So if folks would like to speak up on what you see here, do you see value? Would you use this now that you know about it and how easy it is to use? You put in your zip code and sign up. We'd love to hear from you.
Well, while they're thinking about it, let's talk. I mean, where
Okay.
CHP fits moving forward is CHP remains the most properly applied. CHP remains the most efficient means of generating electricity and thermal energy at one time. The way we've looked at that, we've compared properly applied CHP to, the latest combined cycle combustion turbines, for example, central combustion turbines on natural gas versus natural gas, for example. And properly applied CHP will be lower carbon emissions. Depending on where we are in spark spread, it will be more economical. It certainly saves resource energy. Ergo, that's why it's lower in emissions. And then that same truth would stand whether you go from natural gas to RNG to hydrogen or whatever you're going to go. That inherent physical efficiency difference makes CHP work. That's what's made it work all the time. We do see CHP going in as a large backbone of a lot of microgrids, mainly because it is dispatchable, clean, and resilient. And again, ultimately, as we decarbonize the fuels to the CHP systems, it will be dispatchable, carbon-free eventually energy, which we think is critical because, as we've all looked at the duck curves caused by what happens with PV. We all know that PV is really good when the sun's out, and it's really good up north when the sun's out and it's summer, and it's very different when it's winter and the sun's out. So we have those types of juxtapositions. We also know that wind is very good. Wind will work, particularly offshore wind is going to work very good, and it works better at night than it does during the day. It works better in the winter than it does in the summer. So we know that all of these things are going to contribute to creating energy, creating issues for storage, and creating needs for real dispatchable solutions that can help in the gap, if you will. That's what we see. Does that make sense, Tom?
It sure does. On the line, do we have anyone? New York has been a bit of a challenging environment. I don't know if anyone wants to ask any questions about the New York environment. Does this help you in any way? One thing I see here is that, and I think that Rich did a really good job, if I may say, of addressing how, CHP does speak to a lot of the things. It's CO2 reductions today. It's not technology lock-in. There is a path to distributed emissions-free dispatchable energy, which the ISO says we're going to need 17 gigawatts to 32 gigawatts by 2039. And there's all kinds of interesting applications that we can, quickly spot here. The wastewater treatment plant, the resiliency for hospitals, the food, the combination of local food growing and food resilience, along with the grid resilience. I'm just wondering if you folks see this as a tool. Does this help you in any way? Does this organization of information speak to you like it's speaking to me? And as I said, I know that the environment here has been challenging for CHP in New York, but on the other hand, I think we have a great story to tell. And when I read through this, I see a lot of the strands of the story coming together.
We got a lot of bashful people on the line. Let's have it. You did mention.
Good.
Oh.
Tom Pawinski, I'm glad to hear from you.
So I worked in a variety of places, one of which briefly was the New York Power Pool prior to the ISO. Right now, there's a big push to convert everything to electric. We're looking at electric vehicles, replacing combustion type heating systems in homes, with heat pumps. So depending on the coefficient of performance of those heat pumps, at certain given times, you're buying power from the grid. In New York State right now, if I'm reading the data from the ISO correctly, about 1/3 of the energy is non-combustion type energy. CHP, it would seem, would have a lower impact than a lot of the more traditional combustion generation. But I don't see that really reflected for the people that bid into the ISO. And it would seem to me that if CHP, had some impact into that, it would make a difference on a certain hour you're looking for energy, and your heat pump's COP is close to 1, then how that energy is being generated from the combustion side, becomes important. And I don't see that really reflected in the way the market treats that right now. And I think it would make a big incentive for CHP installations.
Are you talking about, though, as far as merchant plant CHP installations that bid into the ISO? Or are you just talking about emissions in general from CHP plants?
So if I'm bidding into the ISO, I'm bidding. It's pretty much, it looks like it's a dollar value, right? I'm saying I'll give you this amount of generation into the reservoir, if you will, at a certain time period, and it's for a certain dollar amount. It would seem to me that if I'm at a certain period of time and I'm forced to take a lot of that energy from a combustible source, a CHP source is going to be far less of an environmental impact than a traditional combustion power plant. I don't see how that's reflected in the ISO bidding or pricing. And maybe somebody else knows an answer to that, but I don't know.
May I take a crack at that? And I was scanning to see we did have registrations from 2 folks from the ISO, but in the absence of their speaking, Tom, we had a webinar back in January, and I'm going to paraphrase. This is not an exact quote; it's paraphrase. The person who spoke, senior system planner from the ISO, was talking about significant changes coming to the market in the next, 5 years, and something like, the market will change more in the next 5 years than it has in, I don't know, a decade or so or more. So, Tom, while these things are not available yet, I think what you're saying is eminently, it's on the horizon. Okay. And one of the things that I am sure I can quote, because it was stated at that meeting where the ISO spoke, was that they said it's a preferred resource is one that's already on, it's already serving a load, and it can take a signal from the ISO and it can ramp up or down to support the grid. So the conclusion was that CHP may be well primed to do that. And as you stated, Tom, those markets are in development, but this is certainly something we should be watching. This would be good for New York State. It would be good for the environment. It would be good for efficiency, and it would be good for CHP, I think, as you noted.
Yeah, because so it's, take a state like Vermont, where probably more than half the generation right now is non-fossil. Conversion, and there are a lot of programs coming in New York for me to get rid of my gas, fired boiler from my house. I have a hydronic system, and replace it with a heat pump. If I get at certain ambient temperatures right now, hydronic air to water type heat pumps, that they don't perform as well as the air to water ones. So I get down at certain ambient temperatures, I may be using electricity that's, getting it from a source that's throwing all that energy generated, 2/3 of it's going up into the atmosphere. CHP is not going to throw 2/3 of that up into the atmosphere. So there seems to be, when they come up with their pricing or who they accept the bid, there seems to be, there should be a penalty for what your carbon impact is. And in that case, CHP would become far more competitive, I think, than just a traditional bidder into the ISO.
I agree. I'm just going to say, and this is Dan Robb at Frontier Energy. I had helped organize this, but similar to how lots of utilities are shifting to time of use rates, I envision ISOs potentially having to, put some dollar amount on emissions and reflecting that in the rates. And I have heard in conversations with some folks at the New York ISO, future plans to include sort of real-time emissions rates on their sort of dashboards that show all the energy flows and the grid mixes, so that operating decisions from CHP plants can be based on not only economics, but also emissions and when operating and dispatching when they're cleaner than the grid. So I do think, those things are kind of Tom referenced, the changes to the markets that we'll see in the next 5 years.
Yeah, I mean, if you think about it, there's a lot of programs pushing people to convert to heat pumps. If you're getting when your COP is close to 1, and you're getting it from a full and in New York State, 2/3 of the generation right now is some sort of combustible source. Then I think I don't want to use the word carbon tax per se, but it would seem that the CHP would have a far lower environmental impact than just the way the traditional market now is just done with purely economics, purely bid price sort of thing.
Absolutely. Now, we had a conference just a couple weeks ago at June 29th in New York, and one of our featured guests was MIT, the MIT facility manager, the MIT sustainability director, and they just MIT just doubled down on CHP in the face of all that's going on. There's a big push against gas. And the way that they described it was they are now running against a CO2, a carbon signal. So they watch that as much as they watch the economic signal. And I must say that the facility manager was standing side by side with the sustainability director, and they were arm in arm saying, this is good for the environment. We're watching, we're dispatching on CO2. And when we're running this thing, it's helping the grid, it's helping the environment. So, we could and should be doing that here in New York as well, and New Jersey.
Yeah, I know. So there's a company, Next Era, and they're sort of a spin-off from Florida Power, and they put a lot of wind and now they're going to solar generate more in the Midwest. And they were talking about the importance of adding some CHP so they could better improve their ability to bid into that market. So if they say we're going to give you 100, megawatts at a certain time, they're going to be able to do it. At any given time, it might include some mix of CHP, but that's still that overall number they're bidding in is way, way better environmentally and probably price. And I haven't seen a follow up on that, but they were saying that in order to put them in a position to get more of their renewable energy into the grid, they really need to have CHP to sort of keep that flat, load factor, if you will.
Moving away from the home, but back to our industry, though, and that's a good dialogue. I agree. The ancillary services are going to change dramatically, not just with NISO, but a lot of the other ISOs over the next 5 years as well to look at that. But I think CHP has an inherent energy efficiency play that will last. I mean, it's fundamental physics, so that will be there today. It'll be there 20 years from now. So that's interesting to look at. But it also has the ability to have this good running resilience, so it can support a lot of renewables. It can support a lot of new industrial heat pumps, for that matter, that are starting to surface. There's a lot of. I'm not talking residential. I'm talking about large industrial type things that will be coming down the pike in the future. So there's interesting plays. I mean, whether heat pump is a Carnot cycle, so you have to deal with the ambient temperature and manage from the ambient temperature to something. And particularly as you were talking about in winter time, when you've got winter peaking everything going on, you're going to need things like CHP to make the economics work for even large heat pumps. I think you will see that because NYSERDA is or New York State is very interested in putting in large heat pumps into district heating systems, but there's still going to be a play, I believe, personally, not in the future, to rationalize a lot of that with a certain blend of CHP systems for economic and resilience reasons. So any of you folks that are CHP have CHP expertise and need a platform, you need to become a Trade Ally. I showed you how to quickly get in, log in, become a user, and apply to the Trade Ally program. That would make eminent sense. The news and events section gets updated daily, so it is current. It will stay current. The technical elements, the package systems are growing. We're going to be growing, as I say, more, and we're going to add more back pressure turbines and ORCs to this because of the waste to energy elements. It's a great place to find out a lot of information on CHP, not just equipment, but everything else as well. And Tom, it's 2:59.
It's
If there's any other
2:59.
questions, I'll stay as long as you want.
Yep. We'd love to hear questions. Actually, I'd urge if you're willing to speak up, we'd love to hear from you, your thoughts about this, how this helps you. And I just can't put too fine a point on it. This is not just the performance data. This is financing. This is news and events. Rich gave a great tour of this, but looking across here from left to right of all the information that's been organized here, this is just a great data repository. I'm not an engineer, but I'm fascinated by looking at the financing aspects and the resources. So do we have somebody with their hand up? I see a hand raised.
Yeah, Fred.
Hi, can you hear me?
We can.
Yeah.
Yes.
Oh, good. My name's Fred Moss. I'm a New York lawyer, and I write on topics of relating to renewable energy. And I wanted to drill down, if I could, on the notion that CHP provides dispatchable energy. I can understand how, I think as Tom said, you can ramp these up in times when there's greater demand for electricity, but wouldn't it be unlikely that you'd have a simultaneous demand for the heat? And wouldn't the heat in those instances just go into the atmosphere? And if that's the case, doesn't it really just become like a traditional peaker plant at times of high electricity demand?
That's a very good question.
I think the answer to that is it depends.
Yeah.
I mean, again, you've got a variety of very different interesting applications where it can be used, where you will retain the thermal load. Let me give you an example that we find quite fascinating. It's glass greenhouses. Again, where glass greenhouses absorb the thermal load basically in the cold shoulder months and the wintertime to keep the crops growing. It takes the electricity at night to create photosynthesis. And it takes the carbon dioxide from the exhaust, about half of the carbon dioxide in the exhaust, to increase plant growth. So that's 3 different streams it takes. Now, it also has thermal storage on site, because not all the time you're producing the electricity do you need the heat. So you basically have thermal storage tank. So what happens in the case in the wintertime, you will find that wintertime and shoulder seasons, when you need that heat, you can literally shut the lights off, dispatch the electricity for that, and still keep the heat going into the thermal storage tank. That's one example where that does work very well. Now in the summertime, if you wanted to ramp up, you're right, you don't have a place to put the thermal, and then it just becomes the peaker plant. If you need, I will tell you, a reciprocating engine, if that's what you're using, will have a higher heating value efficiency in large sizes, over 42%. Your average peaker turbine is going to be well under that. So it'll still improve over the peaker turbines.
Interesting.
And also, by the way, the peaker turbines, if you're in an industrial side that still uses the heat, it depends on what happens is if the signal goes out and it's worthwhile, the industrial would drop down the power requirements and likely still needs the thermal. In the case of a place like Princeton, although Princeton is changing a lot, Princeton has a 15 megawatt CHP plant. They only run it at 8 megawatts. They've got 15 megawatts that they can go to increase, and they have steam turbine chillers, and they've got a steam loop in the system for now. So there's all sorts. The answer is it depends.
Right.
Very interesting. Thank you very much.
Mm-hmm.
Well, if there are no other questions, I want to thank our presenter. Great job, Rich. I think that this is a spectacular tool. And I thank everybody for showing up. I hope you found this valuable, and more so, I hope when we hang up, you go look at this tool and see if it's useful to you.
Yeah, and sign up. It doesn't cost you a dime.
It doesn't cost you anything.
Nope.
Go out there, give it a spin. And also, as the director of DOE's New York, New Jersey CHP TAP, I want to let you know that we do provide a whole variety of services. If you are interested or know of a business interested in combined heat and power and advice, no cost technical services, please be in touch with us. We will send you all a recording, and we will send you all the slides. Thank you all very much for your attention and time today. Much appreciated. Take care.